This is the second section, Describe Estimation Error. In this section, there are 5 lessons. Let's go ahead and start with the first lessons, Measures of Error. To get this lesson rolling, I've got an exercise for you to do. I want you to estimate these 10 things. Now, this is an estimation exercise, not a lookup exercise, so don't go looking these up. These are for you to try to estimate. Also, time yourself. In class, I usually give people about 4 minutes for this exercise, so I want you to estimate these 10 things. I want you to give an estimate that you have a 90% confidence in. You can and probably should use a range, and make that range neither too wide nor too narrow, just enough to give you that 90% confidence. So go ahead, pause the video here, do the lab, and then come back and see how well you did. Welcome back. Let's go ahead and look at the answers. The first answer is 1769 for the year of Napoleon's birth. Now, if you gave a range from 1760 to 1768, that's not correct because the correct value is 1769. A range that ends in 1768 does not include the correct value. Even though it's close, you don't get to count that one as correct. If you said 1700 to 1800, you do get to count that as correct. Your range is a little bit wider, true, but it does have the correct answer, so you get to count it. Here are the rest of the answers. How'd you do? How many did you get to correct? The task was to create estimates you have 90% confidence in. I'd expect that you would have correctly answered about 9 out of 10. But in over 20 years of teaching this course, I've only had one person ever do that. Most of the time, what people doing the lab achieve is around 3 out of 10 correct. My running average is somewhere right around 3. A few people get 5 to 7, some people got 4, and a lot of people get 1 or 2. And I asked them, why'd you come up with such a low number correct? The task was asking you for 90% confidence. And they would say things like, well, we don't know the answer. I reply, not knowing the answer is why we estimate. The exercise lets you use a range to deal with the fact that you don't know. Then they would say, well, we did use a range, but it was too narrow. I ask, why was it too narrow? They reply, the task said it shouldn't be too wide. The low correct score is from people estimating, focusing on the too wide and not the too narrow part of the instructions. I often ask, why did you make narrow ranges when you know you didn't know? Because, they said, we wanted to give you helpful answers. They gave answers that they had a reasonable belief that were wrong because they didn't know, just to be helpful. Estimates are made so we can give people information to make decisions, and we are giving information that we don't believe in. This seems silly. I realize something else must be going on. Because the ranges are so narrow, they're not trying really to answer the actual value of the estimate question. They're answering a different question. The question I think that they're answering is how good are you or how smart are you? That is the question we all want to answer. We want to tell estimate requesters that we are smart, even though we have no idea what we're talking about in that estimate. I'm going to give you a really, really narrow range because I think a narrow range makes me look smarter when I'm actually being dumber. I'm giving you inaccurate information, but trying to appear as though it's thought out and correct. The other thing I hopefully you notice as you look at your answer is that when your experience is close to the thing that you're trying to estimate, we do a lot better. Like the time to get a signal from the Earth to the moon, because most estimators do well because they kind of already know sort of what the speed of light is. But as it gets further from our experience, like the area of the Sahara Desert or the gross takeoff weight of a 747F, you can see that they're far from our everyday experience, and we tend to do way, way worse on those estimates. Not surprising, we tended to do better estimating things that are very close to our experience. When estimating, we do have various ways we can measure estimation error, and here are some of the most common. You can see lots of different mathematical formulas. The formula that will be used mostly in this course is called balanced relative error. We use that because it reports a consistent positive number as we stray away from the true number, when both overestimating and underestimating. Other formulas tend to work only for one or the other. There's a lot more detailed explanation in the handout. Three notes I think you can walk away with from this particular lesson. First, when faced with high uncertainty, we often give very narrow ranges. We want to tell you how smart we are, then how true the number is. We want to tell you that we're smart people and it's worth working with us. Also, we're often way better estimating things very close to our experience. Typically, it is the small things we're talking about when estimating software projects. So, short work, short tasks. We tend to do a lot better estimating those than longer projects and longer releases. Finally, once we start having this error, there's lots of mathematical ways we can use to express that error.